within the MDA with a specific focus on navigating and growing the international new space economy. Prior to joining the MDA, he was the vice president of a local tech startup while working full-time at Honeywell Aerospace as a power systems and electromechanical engineer. In this role, he worked on systems R&D, design, testing, and qualification for several military and commercial aircraft, including the Airbus A380, A350, F-35 Joint Strike Fighter, and the AW149 helicopter. That's a very impressive list. He has always been passionate about aerospace and robotics and has contributed to several papers in the field. He founded the Autonomous Robotic Systems team in his final year of undergraduate studies in the ECE, Electrical and Computer Engineering at the University of Toronto, and later went on to complete his Master's in Aerospace Engineering from the University of Toronto Institute of Aerospace Studies. Currently holds a PN, Project Management Professional, Six Sigma Green Belt, and one of UFT's elite certifications. Can anyone please give a big hand to Mr. Rohaan?
You guys hear me? Is this thing working?
Yeah.
There you go. Good. Anyone who's comfortable moving to the front, filling this area here, that'd be great. If you're not, that's fine too. So just before I start, I want to see, I don't know most of you are students, so I just want to see how many of you are engineering students. Raise them high, please. And how many people are from out of science and engineering altogether? So no business people here? Well, the former cosmonaut thinks he's a business person. All right, well, today's presentation, so it seems so far everyone who's been here has worked at MDA at some point or is currently working. So what I'm not going to do is go into too much detail about MDA and try to sell you, on MDA as the company. And so what I did is I decided not to bring my the business development presentation that we usually have here. What I did is something outside what I thought was outside the box, and I said, when I was a student and I wanted to work in aerospace, particularly space, what information would I have liked to receive if I were on your end about the current space industry? So I sort of designed this from scratch. It's not going to be comprehensive because honestly, there's slides in there where you could give. I have given 2-hour seminars on just one topic of on-orbit servicing. In this one presentation, I have just one bullet point about it. So space is huge. I'm just going to try to cover it all in the next 20 minutes. All right? Thanks. Oh, and also thanks for coming back after lunch, because usually when I was a student, as soon as I had lunch, I was out. So that's the agenda today. I'm going to talk about myself, not for too long so you guys don't fall asleep because you just ate. And I'm going to talk about traditional space versus new space. Some of the conversation I've had today, I'm really happy about because that is essentially what the topic is going to be today. I'm going to try to cover what is happening in space right now. We're going to talk about challenges and opportunities. And when we're talking about that, I want you to think, regardless of whether you're in engineering or not, I want you to think how. Oh, I broke this. I'll put him up. I want you to think about how what you're learning right now, what you're studying right now applies to this, and how you would want to change this, how you would address these challenges, because that's really what it's about. It's about presenting these challenges to you, and then you guys might come up with the next SpaceX or the next Blue Origin in your brains or the people around you. So just think about that. I'm going to tell you a little bit about government versus commercial climate in space, and then I'm going to go right into the opportunities for Canadians, particularly Canadian students. So, what programs have I worked on? Pictures on the right show you some of the programs that I've worked on. This is the ExoMars 2020 rover, which will be launched to Mars next year. Recently, it was given a name. It's called Rosalind Franklin, the rover. Because the British wanted to name it after some British person, I guess. I was incensed. I went to BBC. If you read the BBC article about it, you will never know that Canada even worked on this program. It looks like they built the entire thing in England. Whereas it was built in, I worked with people from Switzerland to Canada to France on this project. And yet, if you read the BBC article, there's no mention of that. So I mean, I was a little angry. I just wanted at least the people in this room to know that Canada did the bogie electromechanical assembly, so that's the wheels, the sort of the chassis, the bogies, and the drive electronics. I'm also working on the Deep Space Gateway Robotics, which is this. So think about that as the next International Space Station, but instead of being in low Earth orbit around Earth, it's going to be in orbit around the moon. And it's the next step to space exploration. It's going to be the next big collaborative international project, and it's going to be different in one very specific way, which I will cover soon. On-orbit satellite servicing, so that's right here. This satellite, we also saw in Eric's presentation, is NBSat. It's in sun-synchronous orbit and is now dead, and it cannot be revived. So it's one example of space debris. It's the size of the school bus, by the way. And what we've done is we're designing ways this is called a bus, this is called a robotic arm. We're designing ways of how we can reduce space debris. And recently I worked on a project with Airbus, and it was Germany, to how do we deorbit something like this. And as you can imagine, it's a challenging project because we've got to take something from space and bring it back to Earth. I'm working on Constellation projects, Constellation satellites, so things like the OneWeb Constellation. OneWeb is a company that wants to send 800 or so small sats into space to provide internet coverage around the world. And then at Honeywell, I worked on aircraft project, including the F-35 power thermal management system. Before that, I was a student much like yourself at U of T. I did my bachelor's in applied science and electrical and computer engineering. So one story that I've been telling some people is that in my final year of BCE, I took a course in aerospace called the aircraft design course, the AR 410 or something like that. And I was the only, by the way, I took that course, don't tell anybody. But I took that course, so if you go as an ECE to aerospace and you say, I want to take this course, they say, no, it's only for aerospace students. But if you go into, back then I think it was Magellan, or Rosie, or one of the systems, and you just enroll in the course, they never find out. So that's how I took the course. This was my first course, and I never asked permission, I just took it. And there were 31 students in class, 30 of them were aerospace engineers, and one was ECE. Guess who was the only one to get a job in an aerospace company by the end of it? It was the one ECE. So if there's any ECEs in here, I got you. And then after I started working in aerospace, I did a part-time master's at UTIS. That's the extent of what I'm going to talk about myself. So pre-2000s, we were living in a traditional age of space. Essentially, governments and defense needs dictated what we needed to be up in space. They would put in big chunks of money on projects, and then commercial companies wouldn't take part like MBA, but essentially the risk and the cost all was covered by these government entities. So we had a lot of single, one-off, this is supposed to be ONE, one-off missions. So we would send up a satellite, for example, for 4 years, and then it would die and just stay there. And we wouldn't use it because that's how government is very efficient. If anyone's worked in the government here, you realize there's a lot of things that can improve in government efficiency. We had a lot of non-reusable vehicles except for the space shuttle, which was supposed to be reusable, but it ended up being too expensive. And we had a lot of large, complex satellites, including NBSat, for example. And these big satellites used to take anything from 2 years to 6 years to build. So there were large costs and large lead times associated with them, and there were a few major players. So there was a top tier that consisted almost entirely of the United States and Russia in terms of putting money into space, and then there was a second tier in which Canada, Europe, Japan, and China fell. That was pre-2000s. Let's call that traditional space. Here's the word that everyone's been using, and it's a buzzword. It's a buzzword because when I was an undergrad, I did a certification in sustainable engineering, and I learned that sustainable can be whatever you want it to be. The word sustainable can mean anything. So there are companies that are oil and gas companies like British Petroleum that have won awards in sustainability. And if you went to somebody from Greenpeace whose idea of sustainability is completely different, they would hold their head. Like, what? How is BP sustainable? Right? So new space can really mean whatever you want it to mean. Just like the word innovation, just like the word disruption. Really though, what it means is in my opinion, and you can disagree, is now space is becoming democratized. It is becoming more open to the general folk, to commercial companies, to private companies. And what's driving that is the need, well, we were talking about this outside. We figured out that by going into space, we can actually make money. And since we can make money, now we want to get there as private citizens, as commercial enterprise. So it's called commercialization, privatization of space. There's a lot more what they call public-private partnerships, PPPs or OTA contracts, where the risks and the costs are now shared between commercial and public entities. So the government of Canada, for example, whereas previously they would spend money on building a satellite and sending it to space, now they say, well, we are willing to spend $20 million on buying this particular set of information. And they say, commercial industry, go do what you need to do, get me that information. I don't care. If you need to build a satellite, you fund that, I'll help you with that capacity, but we need this information. This is the end goal. That's what the government will spend money on. So that's what I mean here by large institutions buy capability and they invest in capacity, so the government would invest. And then commercial partners build the capacity and then they sell the capability. So think about yourself, for example, if you were to start a company that does anything in space, you would be essentially building the capability and selling it. It's driven by commercial business and information defense needs. It utilizes low cost engineering, manufacturing, reusability, multi-use of aircraft and spacecraft. And again, some buzzwords, because I just like to put buzzwords up there. Give me whatever you want it to be. Challenge and opportunity. So remember what I told you. I want you to be thinking about how, if I were to come up to you 5 minutes from now and say, how would you solve this problem? I want your gears to be turning. Because that's the objective of this presentation. So probably the biggest area of change in space right now, because of new space, is satellites. We're moving from large, complex satellites to smaller, more cheaper satellites that are easier to deploy, and then we're moving to a constellation satellite. Just a question, by the way, why would you send up constellation satellites rather than constellations? Why would you send up constellation satellites in low Earth orbit rather than constellation satellites in geo orbit? By the way, those who don't know, low Earth orbit is around 400 to 2,000 kilometers. Geo orbit is about 40,000 kilometers. So, any guesses? So constellation is something like this. So you, instead of sending one satellite into space to do the task, you send multiple. And then they communicate with each other and they sort of synchronize and then send data down. Sorry, go, he was first.
So if you, for example, need to cover an area on the Earth with a signal, which is usually geostationary is used for, it's a lot easier to send a bunch of really small light things to zip around in low Earth orbit and just make sure that there's enough of them to always be in sight of one, than to send one gigantic, huge geostationary satellite to 36,000 kilometers away.
Exactly. So roughly the answer is correct. That's exactly what I was going to say. It's a lot cheaper. It's cheaper to send 3 satellites. So one project that Eric mentioned is called the RadarSat Constellation mission. The objective is that Canada wants the ability to have communications in the Arctic regions. Why would you send 3? Because they're not always going to, the one satellite is not always going to be visible. And it's cheaper to send something 2,000 kilometers than it is to send 40,000 kilometers. What are the uses of this? Well, it's being used for broadband internet, for global communication, to collect data about climate change, and it uses for remote sensing and Earth observation. And this is sort of a plug here. Somebody was asking me, what is the use of AI in space? Imagine having information from images that you're collecting, but having to sift through them manually. You can't. I mean, it takes a long time. This is AI and machine learning in particular is a field where you can just feed information into the computer, and it will look at all the images and be able to identify, for example, ships, and compare that to where the ships are supposed to be. And you say, well, there's not supposed to be a ship in this area at this time, and now you know that there might be something fishy going on, and you can actually send resources, take a close look. This is actually something that the Canadian National Defense very interested in this little thing. On a quick side note, by the way, I know I got another tangent, but there was a recent, there was a conference in Vancouver recently called the NeuroAssist or NeuroEpic. And there were companies from the United States that were there. InQtel is a conglomerate of, it has Google, CIA, etc. It's just one of many companies that are interested in machine learning and deep learning. And they were literally going to the conference, and if you had a master's degree in AI or software engineering, they would talk to you for a few minutes, and they would give you a card and say, can I have 15 minutes or 20 minutes of your time this afternoon? They would take you to a room, interview you, and give you a job right there, starting at $150,000. AI, I'm telling you, get into that. Oh, actually, don't get into that. Come to MDA. I'm not going to spend too much time here, mainly because I'm intimidated by the doctor who's going to speak at the end today. He's an expert in launch vehicles. But this is an area of development right now. And ultimately, it's driven by this thing right here. This thing right here. Reducing the launch and transport costs per kilogram. And how do they do that? Well, you use low-cost manufacturing production techniques. You maximize the reusability and increase the volume. Now, anyone here lift weights? Sir? Oh, all right, go ahead. What is volume to you as when you're lifting weights? What is volume to you? And weights? Go ahead.
It's like a total amount of weight that you lift over like a given amount.
Exactly. And then that's calculated based on what?
It's just the number of times you lift it times the weight.
The number of times, the weight you're lifting, and then the number of times you lift. Great. You can flex now. So my bro here, my swole bro, has answered the question correctly. So by increasing the volume, you can reduce the size, you can reduce the cost it is to launch individual kilograms. So by launching instead of once a year, 5 times a year, you can actually, and then utilizing all the volume, all the space within it, you can actually reduce the per mission cost. So that's another thing they're trying to do. So this thing you see SpaceX do right here, it's not just Elon Musk who go on Tinder and be like, oh, I land rockets on their back. It's so that I have my sister here who was laughing at my jokes. She's the only one. It's so that they don't have to do reconstruction. They don't have a long turnaround time. So the space shuttle, for example, for it to be cost effective, and when they were first designing it, it had to fly into space anywhere from 15 to 50 times a year. We never got close to that. So the space shuttle program was eventually shut down because the turnaround time was too slow. They couldn't launch missions fast enough. There wasn't demand for it, and it was too expensive. So that's what they're trying to do here. They're trying to minimize the turnaround time and refurbishment time, etc. Oh, and sorry, I didn't just want to concentrate on the rockets. I also want to concentrate on this. I was fortunate enough last year in Germany to see the first manned Orion spacecraft that will fly being constructed, and it was something to behold. It was beautiful. Another area of new space that is very close to me is space exploration. I've already talked about Deep Space Gateway. It's essentially going to be a space station in lunar orbit. So the current space station, anyone know how far away it is from Earth? It's in low Earth orbit, but roughly how far? Take a guess. Yes. 400. Yes. Good enough. Probably 500. All right. This one is going to be more than 1,000 times away than that. It's going to be in cislunar orbit. So what can be some of the challenges that you think would occur when you're operating that far away from Earth? Yes, sir?
You probably lose communication on the side of the moon.
Yes. Well, depending on your orbit around the moon, yes. Yes.
Delayed communication time?
Exactly. Latency. What else? Think about the slide before this, about launch vehicles and spacecraft.
Expensive.
It's farther, so you have to carry mass longer distance, which is more expensive, right? So that is a problem right now that we're trying to solve. And again, there's an opportunity for software, robotics, and AI to come into play. And when you're operating, so I can tell you right now, and maybe Kristen covered this morning, when you're operating the Canadarm from Earth on the ISS, it's almost zero delay. It's barely noticeable because the computation delay is almost as long as the delay of time communication. It's only 4 kilometers. To the moon and back is about 2 seconds, just below 2 seconds. After that computation delay, maybe dropouts. When I worked on my last project, I estimated it to be around 5 to 6 second delay, worst case scenario. That's when we have communication. When we don't have communication, we might lose it for a few hours to a few days. So you need your robotics on board, and you have millions of dollars worth of robots on something like this. You want them to be smart enough to be able to do the job. You send a command, and they'll just do it. And you want them to be smart enough to know that when something's going wrong, they need to stop and wait for the next command. So that's where, again, AI and robotics come into play. The objective of this deep space gateway is to, oh, sorry, yes.
Yeah, I have a question about the previous one. Why can't the crew members on board do the task? Why does it have to be on the ground?
Oh, so you mean on the ISS?
Yeah.
So the ISS robotic arm is controlled, can be controlled from the space station. In fact, we have 2 workstations, and you can go to either one and control the arm. But it is usually done by ground because the time that the crew members have on board is very crucial. So what we try to do is we try to limit their as much as we can do remotely, we do, so that their time is best spent on their experimentation tasks. Almost exclusively now, the Canadarm is operated from the ground. Whereas the first person to operate it ever from space was Chris Hadfield. So this is an artist's concept of what this deep space gateway is going to look like. That's supposed to be Earth, and this is supposed to be Moon. You can't tell. And that little arm is what I did the conceptual design of recently. The objective of this thing will be first to take us to the moon and keep us there this time. And like they said, there's commercial value to being on the moon. And why is there commercial value to being on the moon? Because it allows us to go to Mars. I'm talking about manned missions, and it allows us to go to asteroids. NASA recently came out with news that they're going to test out an asteroid redirect mission. Who here saw Armageddon, by the way? Just 3 people? 3 people saw Armageddon? Well, everything in that movie is real. It actually happened. So instead of sending a bunch of Bruce Willises to there and mining experts, we're actually going to send robots and rovers to these asteroids to do what we call planetary seeds. By the way, if you're not laughing at my jokes, I work really hard at it. Because I have a second career as a stand-up comedian just in my bathroom. Another thing that I found out recently is there's a company in Canada operating called, it's a new startup company, which is trying to build autonomous spacecraft for space. So, which makes perfect sense. But they're really using AI to do their work, and I believe they're going to have a recruitment session here at UT at some point. So. And ultimately, the goal is to colonize Mars, as Elon Musk says. Elon Musk is not the only one who wants to colonize Mars, by the way. I've spoken with people in the Middle East who say they're going to get there first. So. Don't laugh, because they have a lot of money. I wish Canada had that money. We'd be on Neptune by now. Next one. I like this graphic. Obviously, the dots are exaggerated, but all of this is an actual representation of satellites in space right now, of objects in space right now. Currently, there are around 2,800 large enough bodies in space. In the next 15 years, there's going to be 20,000 bodies in space. That's what we call space debris. That's just a lot of junk floating around in low Earth orbit mostly. And it's a problem, because it includes old dead satellites, launch vehicle debris, currently active satellites, and new constellation satellites. So let's do the math. SpaceX wants to send over 1,000 satellites into low Earth orbit. OneWeb wants to send 810. Kepler Communications wants to send 400 and something. Swarm Technologies, which started, co-founded by by a person from UTIS in Toronto, in Silicon Valley. They want to send up something like 300 satellites. And then there's a whole bunch of other companies that want to send up more and more satellites. And no one's really caring about the space debris. Imagine trying to launch stuff when there's that much gunk in space. Well, that's a problem, and we need to do something about it. Right now, there's no guidance, there's no regulation that says you need to deorbit your satellite after its mission is completed. So, there's this thing called Kessler syndrome, which was, you know Phil Kessler? The hockey player?
Yeah.
He wasn't the one who said this, because he's taking too many hits to the head. I don't think he's smart enough to come up with this, but, or maybe he is.
Oh.
Actually, his name is not Kessler, is it? It's Phil Kessler.
Yeah.
Crap. He came up with this idea of cascading collision, and he said that at some point, we're going to have so much gunk in space that one collision is going to create 1,000 more particles, which is going to create more collisions, which is going to create more collisions, and eventually it's going to be almost impossible for us to send things into space. So what is the solution? Well, you clean up old junk and you prevent new junk from forming. And there's many ways of doing that. I've worked on one technology that is, like I said, the MDSAT robotic deorbiting. There are other ways. So you guys are smart here. Think about ways that you can clean up space. Just like how we, at the start of the Industrial Revolution, we thought the world's waterways and the oceans are too big for us to pollute, and so we just dumped everything in there. We've sort of done the space, same thing with space. And eventually, we're going to reach a point where we're going to have to clean it up. Space mining. Did you know that an asteroid the size of football fields has minerals and elements that are worth billions, tens of billions of dollars? Well, we know that now. This is Bennu, an asteroid, and this is a mission that is currently on, this is an MDA mission. Well, other people worked on it, but I don't even claim MDA is. We built the laser altimeter for it. It's going to go and touch this Bennu asteroid and collect a sample in this thing called a tag SAM, and it's going to bring it back to Earth. Now, this is a purely, sorry, yes?
Do you think with the introduction of asteroid mining, wouldn't the oversaturation of the market for these materials drive the price down and kind of make it not worth it?
Only if enough people are able to do it. Imagine if there were only 2 countries in the world who were able to do it. They would essentially. Okay, so that's a more geoeconomic question, but I'm going to assume that if I'm the United States or China and I go and capture a satellite that has like Ryugu, which has $30 billion worth of profit on it, I'm not talking about revenue or value. The cost of going there, extracting and bring it back, you can make $30 billion. You think the first country who gets there is going to give it up for free? Yes,
Yeah,
sir?
but wasn't this a similar argument when fracking was introduced to natural gas in 2005, where they said that the Alberta economy still had like $2 trillion worth of natural gas, and then it went down 25,000% or something? 2,500%.
It might have been. So I'm not an economics professor. I cannot answer this question about would it drive the prices down or not. I can tell you that for sure there are a lot of countries, including Luxembourg, including China, including United Arab Emirates, that are very interested in going and getting these resources for 2 reasons. The first is to bring things like gold and silver and platinum back to Earth. And the second is actually what we call ISRU, Insight Resource Utilization. So, like I said, it's very expensive to carry stuff into space for long distances. So say we go to Mars or wherever and we want to carry as little stuff as possible. Well, we can extract iron, aluminum, titanium from these asteroids or from Martian atmosphere or whatever, and build things right there using additive manufacturing technology or 3D printing or whatever you call it. Look at that. If one of you guys build something that can go into space and then get this $30 billion, please remember this face. I'm going to come collecting money. So this point leads very much into the next point. Imagine the first country to go is, I don't know, we're going to call it Maya. Maya is the first country to go into space and collect and capture Ryugu. Do you think they're going to want other countries to come there? I don't think so. They're going to want to do something called denial of space. They're going to want to deny space to other people. Space warfare is actually a huge concern in Canada because recently I had the opportunity to hear and speak with Kevin Whale, who's the Director General of the Space Command, or not the Space Command, the Space Component in the DND. And he has this initiative called the Strong Security Engage Program. And he's very adamant that we need to do something to make sure that Canada stays abreast of space threats. What kind of space threats are there? You can't really see it. This was a graphic put out by the US Aerospace Intelligence. Essentially, you have jammers, you have radiated microwave devices. These are things that people can do to our satellites. In peacetime, we might not even know that they did it. We might just think our satellite is not functioning. They can actually use our satellites and our information to spy on us without us realizing that this actually happened. They can use kinetic kill weaponry. We might just think our satellite is not functioning. They can actually use our satellites and our information to spy on us without us realizing that this actually happened. They can use kinetic kill weaponry, which is, there are 4 countries in the world that for sure have kinetic kill. So kinetic kill is like the caveman technology of space age. It's you go and hit a satellite with a missile. It breaks apart in chunks. By the way, interesting point here. Last time there was an anti-satellite test done by China, there were 9,000 pieces of space to be created. So clearly, this is going to be a big problem. And this is not going to be driven by the commercial people per se, but you will be required if you decide to, create a commercial company that does space warfare. In which case, please don't spy on me. But if you were to, the DND will come to you and say, we need something that is capable of, monitoring space and giving us early warning of when there's this threat coming in. So that's the kind of problem that you will have to do. So those are the challenges and opportunities. Any question on that part, by the way? Yes, sir.
What's your opinion on the use of graveyard orbits as opposed to deorbiting?
It's frowned upon. So we've actually done that, and both ESA and NASA don't want us pushing things into graveyard orbits. They want us to deorbit them. The reason for that is political. You push something in graveyard orbit. By the way, graveyard orbit is just beyond geo orbit. You essentially take dead satellites or debris and push it out further into space. As a general rule, it's not. We don't want to be the civilization. Human beings don't want to be the people who take their junk and just throw it into space. If we can deorbit it, we'd like to deorbit it. But yes, that's definitely an option. For example, it's an option for Constellation satellites, because you can't. It's hard to deorbit 800 satellites, but it's easier to push a few of them away. Although there's a point in here I forgot to make on on-orbit servicing. So on-orbit servicing is right there, on-orbit servicing. I want to talk about this. This is something very interesting to me. This is going to be a purely commercial enterprise, in my opinion. And what it's going to be is going to be satellites like these, a spacecraft like these that are going to go up. And so, say company X wants to send up a huge satellite into space. Well, they don't want to spend the money on sending all of it together. They want to send it up in chunks and pieces. Well, something like this can go up and build it in space, go and do inspection on other satellites, repair objects, refuel them, etc. And this is going to be a multi-billion-dollar industry on its own. And I've been fortunate enough to work on at least 2 iterations of this. One with Airbus, one with Thales in France. And I think it's going to be, the reason I wanted to come back to this is because you guys are interested in robotics and making money.
Question?
Yes, sir.
So you're saying like there's a trend moving towards sending small sats into low Earth orbit, right? Instead of sending them to geo. Isn't that a good thing for space debris? Because LEO naturally deorbits after like a short amount of time. Within a year.
Not if they have GC systems that's supposed to keep them in space. You mean if they die?
No, like deorbit, burn up the atmosphere.
I don't think not all DOs do that, otherwise they just fall into the ground.
Yeah, that's called itself, keep it in orbit.
Yeah, so if you're saying if the GNC completely dies out?
Well, you could purposely put things into
Oh.
a LEO that, you know.
So one of the things that a lot of companies are trying to do now is this exactly that. So when the satellite dies out, it just sort of spirals down. So that's one way of mitigating. It wasn't something people were thinking about it until now. The current climate. The international space industry is, if you can't see this graphic, but essentially these bigger and bigger space shuttles mean that every year the amount of money being pushed into space is increasing by the countries around the world. Governments are spending more and more. There are new players coming in, so old players like USA, Russia, China, Europe, they're all investing more money, all of them. And they're new companies. All of these countries, roughly 50 countries in the last 2 years have either created or expanded their space agency. These being the ones that I've noted. UAE recently, not only do they own, I believe, 50% or 49% of Virgin Galactic, but they also have their own space agency that they've put billions of dollars into recently. Saudi Arabia is spending money. The UK wants to own, the UK being UK, wants to own 10% of all space market in the next 10 years. Because Brexit. Australia has just come up with their space agency, and actually they want to model their space agency after the Canadians. Luxembourg, a small European country, wants to be the world leader in space mining. They want to be the world leader in space mining because they realize the $30 billion I was talking about. And then there's a whole bunch of other countries, including South Korea, Pakistan, Algeria, they're expanding their space programs. Everyone except Canada. Canada is not putting any money, any new money into space at all. On the private side, the next international space station that I was talking about is going to be public-private partnership. There are, according to some venture capital firms, there are hundreds of applications they receive for space startups a month, of which dozens get funded. And so the door is wide open for new players, for new commercial entities. You see this graph? You can't really see that well, but this is 412 is the number of companies that have received, in the US alone, space tech firms that have received venture capital funding in 2018 versus 2010. Look at that. Many time increase. And this, again, you can't see it because it's not large enough, but there's a company called Seraphim, which is a venture capital firm for space tech, and this is just the companies that they feel are actually worth investing money into. Look at that number. That has, SpaceX and Kepler Communications all in mind. And the reason I'm telling you this is because there are a few established players, yes, in Canada, but there's nothing stopping you guys, if you have an idea, from pursuing one of these, challenges on your own. Opportunities for Canada and Canadians. At the student level, Eric made a really good point in his presentation. Everyone's paths are different. Mine sort of followed where I got out of school and I tried to become an expert in certain fields. So I did electromagnetism systems, power system engineering at Honeywell, moved to MBA, did more systems engineering, and became, in my opinion, reasonably good at the system stuff, and then now I'm branching off into business development, which is essentially one of the reasons why I'm here. Another thing we need to learn at an individual level is after you mastered your technology or your understanding. And by the way, technology doesn't have to be like a specific, it doesn't have to be AI. You can just be really good at, if you're studying economics or finance or whatever, you can be really good at that trade. You just have to be really good at what you are so you can be valuable to the company. Here I use technology because most of you guys are going to be engineers. Another thing that we're usually not very good at, but we need to be good at, is you need to identify other people who are really good at what they're doing, and you need to be able to work with them. It's particularly in space and in aircraft systems, you're working with people from around the world. Some of them speak great English, some of them speak mostly, not very great English. And you need to work with them, different time zones. Being able to work with experts across the world, especially in your company, is very important. And then the third thing you need to be able to do is you need to be able to market yourself and your ideas at the individual level. You can then go in and join one of these established companies. Sorry, Eric, I should put Magellan up there. I apologize. I really should. Or you can go to one of these new companies. So Mission Control is that company I was talking about, the one that's doing the autonomous spacecraft. And Space Horizon I put on there because I knew you were coming. And then there are a whole bunch of entrepreneurship opportunities for you as well. So, for example, the Creative Destructive Lab at U of T has a space stream now, which is funded by the government and some industry sponsors. So if you have a space idea, you can go to them and they can help you bring it to life. And then there's U of T Hatching Horizons, DMZ, UTM's IQ, or you can contact MD Launchpad like Nicholas told you about earlier. And if all else fails, you can move to USA, Europe, Middle East, where they actually value space engineers. Why? Why am I so bitter? Because of this. We've fallen from 8th to 18th in the world in terms of GDP and space spending. We are, without a doubt. Okay, let me tell you this right now. Without a doubt, when you're traveling, when you work in this industry, we are leaders. People give us respect just for being Canadian because of the stuff that we've done in space. So last year I was in Airbus at Germany, and we were sitting around a table, and there were companies from Spain, there were companies from Portugal, Poland, Germany, and us. And it was very obvious from the first day that it didn't even matter if the question was not related to my work package. If they needed expert advice, they would come to us because they understood that we've done this a million times, we're good at this, right? We have a lot of good things that we've done in space, but that's, you understand how, we're like, who's here is a soccer fan? Nobody? Well, you know Manchester United, the team that used to be great, but now their fans, all they talk about is the past. Well, Canada is becoming that. Right? We're becoming, oh, we used to be great at this. But we have nothing coming up right now. We're not doing anything great at this moment. Well, we are, but we won't be doing it for too long. There will be other companies, other countries that will come up and overtake us. So Canada was involved in ExoMars 2020 because we have experience, in space. There's no reason why 10 years down the line, when somebody's building another Mars rover, they would come to Canada unless our government says, we're interested in working in space. Why do we need to be in space? I mean, you could just ask, why do we need to spend money in space? Why not in energy or whatever? Well, there's a few reasons. One, we want to be the global leader, right, in space. Two, we want to create those space space jobs and talent. So like I said, right now the industry is worth $380 billion. It's going to go up to over $1 trillion, multi-trillion dollars in fact. And if you invest now, you will get that reward. It's just basic. I'm not an economics professor, but I understand that much at least. And the last reason is the fact that we need to defend ourselves against space threats. That is also, so for border security, for national defense, for the security of our information. We cannot be, in my opinion, entirely reliant on the United States for our national defense. It's just something that doesn't sit right with me as a Canadian. So what can you do to help with this? Well, you can do this. You can go to this website, Don't Let Go Canada. Take your phone down and go there right now. I'm not kidding. Go there and you can contact your MP. If you want to work in space or aerospace, get to this website and contact your MP and create some noise. Go on Twitter or Facebook and put my picture up and say, handsomest guy I've ever seen. And then go hashtag Don't Let Go Canada. Because we need to be in space. I mean, I need a job, of course. You guys also want to work in space. And that brings me to the end of my presentation. Quick question. How many lines of code do you think the Canadarm runs on? You're not allowed to answer. 100,000. You can guess. I'll give it to whoever's closest. 100,000?
No, like, definitely over 1 million.
Over 1 million? Over a billion lines of code. Yes. 1.5 million. Any other guesses?
50?
50,000?
No, just 50.
500,000.
You Google that.
No, I didn't. I swear.
You Google that. Go check his desktop.
No, he's good. He's good.
I'm doing my controls homework.
$550,000. Sorry.
Coats.
Is what you need to give me. Is what you need to give me if you want the prize. 550,000 lines of code. And I can tell you, not one of you has a phone that is worse than the computer on the counter. So just for comparison, by the way, 550,000 lines of code is roughly Windows Vista. And Windows Vista, right? Yeah, the cheater, yeah. And it's running on the computer that is, well, I can't tell you exactly how bad it is, but even when you were a kid, your first computer was better than that. That's a feat. And that's because of people like Nicholas who make that work. Any questions, guys? Also, feel free to add me on LinkedIn. Yes.
So, how do you think the whole world is going to deal with the tracking issue for this? Like for instance, Swarm, what you brought up, and their recent fiasco.
Yeah.
How are we going to be able to track satellites that are getting smaller and smaller and smaller if all we have is ground-based radar?
Well, right now we can track anything. I believe 10 centimeters above.
But I mean, they're making satellites that are like that.
Yeah, so that's exactly one of the challenges. How do you track that? So you want, one of the things that we want in space, one of the things that Kevin Whale, who's the director of National Components, says, we want to be able to track smaller things. And you do that by putting radars in space and looking at space itself. So that's one thing that needs to develop. So if you have an idea for how to do that, send them a satellite in space and monitor. Let's invest in it together. Yes, sir.
How difficult was the transition for you to go from EC to aerospace engineering?
Very easy, because EC is a little bit better. And we're smarter.
Is there anything that you have to do to catch up in order to transition to aerospace?
Yeah, so I'll tell you what. So right now when I sit in a meeting, so I did EC. So in EC we study electrical, we study computer, right? What are the main areas in aerospace that people study? By the way, aerospace in general, when you go to aerospace stream, you study a lot of systems, right? And you do study, like, you do dive deep into your areas as well when you pick something, but at the overall level, it's systems, right? In EC, we just dive straight in. We just learn about coding, about electronics, about hardware, and everything. So when I came out and I went to aerospace, I realized that when they were talking about, when the software guy was talking about software, I understood 100%. When the electrical guy was talking electrical, I understood. Electronics, I understood. The place where I fell short was when they were talking about stresses and joint loads, and when they were talking about materials, and that stuff that I had to learn. I did a very stupid thing. I took a master's course in at UTIUS, I don't remember the name anymore. In my final year of master's, I took a course in material sciences or something. And pretty much almost nearly failed that. Like, I had to go to the professor and be like, sir, I don't know the difference between stress and strain. And then he looked at me like, oh, why are you here? Why are you even here? Why are you wasting my time? But anyway, I had to learn all that, because we don't learn that in EC, right? I actually, to be honest, to this day, do not know the difference. Any mechanical engineers who want to give this explanation? Stress versus strain? Yes.
What, like actually?
Yeah.
Oh. Strain is the percent which the like distance or the length of, let's say, a beam changes when you load it as compared to its original length. And strain is the amount of force you're applying divided by the cross section of that beam. So like a pressure.
I have no idea if that's correct. Let's assume it is.
I'm very sorry. I said stress was the second, right? Yeah.
I figured that.
What? Oh, whoops.
I figured that.
The second one was stress.
Well, stress is what you are right now. Yes, sir.
Canada might not be doing too much to stay caught up in aerospace, but are Canadian companies pushing that agenda?
Yeah, so there's so many startups in Canada that, so from two perspectives, from the startup perspective, yes, there's a lot of companies coming up. Silicon Valley might be the place where all the popular ones are, but in Canada, we're not far behind. We're actually, Canada in general, Toronto in particular, is really good for startups. We're actually very fortunate here. And one thing that we have here in Canada, and I can say this because I'm at U of T, is we have, when it comes to capacity, and capacity is essentially you people, the capacity for aerospace is really good. We have some really good aerospace institutions here. U of T, Rohaan. We have, I mean, in general, I'm being honest here. There are Europeans who love having people from and Americans who love having people from Canada. Sorry, just to finish up that question. The second part of that is what a company like Magellan, MDA, and established players doing. Well, we're collaborating with people from around the world. So instead of just relying on the government, we're also collaborating with companies like SpaceX and OneWeb. I've worked with OneWeb. My colleagues have worked with SpaceX. We're getting better at how to work with companies around the world. And again, like I said, one of my mandates now is to see how we can expand into the Middle East and South Asia. It was one of the bullet points. That's an initiative that I've been taking at MBA. So they're expanding that way. And the second thing we're doing is really pushing this Don't Let Go Canada thing, because we really want Canadian government to spend money on space. Yes. Who did I point to last time? Yes.
Yeah, alright. So there's news recently of a planned spaceport in Canada, in Nova Scotia. I don't know if you heard about that, if you got any thoughts about that, and if you think that's going to be like
that would be a great idea, the question to ask the doctor. But as far as I'm aware, Canada has had one spaceport, and that was a long time ago. Is that right, Eric?
It was the Churchill. That's been active
not have a spaceport. Spaceport in Canada, if you're asking me does that make sense? Is that something we need to have? I think we should. But from a commercial perspective, I've never looked into it. Yes, sir.
So with the increasing, so if say I wanted to work for SpaceX, I would have to become an American citizen because rockets are considered like weapons.
Why would you in the first place?
Well, just saying if I wanted to. With the increasing privatization of the space industry, do you think laws like that are become like less strict to allow for companies to really monopolize on the best talent, or do you think it's going to become more nationalistic?
I think it's going to become less because regulations are on the way. So one of the reasons why SpaceX you have to be U.S. citizens because of the government, because of government regulations. That's why Elon Musk also had to become American for some reason. Is because you can't work on defense projects, you can't transport defense satellites, for example, if you're a Canadian company. Right? That's one of the reasons why MDA, the company that I work for, became Maxar, which is headquartered in the U.S. And I saw Eric take a shot at us at the beginning of his presentation. He's like, "Oh, we're a purely Canadian company." I can't say that. 'Cause even though MDA is Canadian, Maxar is not. And one of the reasons we did that is so we could get those American projects. But I think it's going to go down. I think it does make sense for that to stay up to a level. Because there's going to be a lot more cross collaboration across the board. And so the regulations will fall down. One thing, by the way, SpaceX, I want to go work for them. It's a great company. There's a huge hype, but one of the ways that these companies like Blue Origin and SpaceX keep their costs down is one, they don't pay really well. Two, they make you work much harder than other companies in the area would make you work. Government institutions, for example. And the third thing is there were recently layoffs in both SpaceX and Blue Origin. Because essentially what they do is one of their strategies, during the development cycle, they'll hire a lot of engineers and developers, and as soon as they're past the development cycle into production, they'll let some of that go, some of those people go. And that makes sense, perfect sense in this economy where it's about, reducing your costs now, but those, 50 or 100 people that you laid off who are now rocket engineers are gonna go somewhere. So in the long term, I think it's gonna backfire on them. So that's just a side note. That's to make sure you don't work for SpaceX. I'm just kidding. You can if you like. Any more questions, guys? All right. Thank you very much.
Thank you very much, Rohaan, for the very detailed presentation. There are some questions that I needed answering to, and you touched on them quite well. Our team would like to give you also a gift.
Thank you.
So we're just going to have our third round of trivia, and we're going to quickly